If you are watching these in order, this is where we left off on the first video. Now what we're going to do next is something called velocity vector. Now a velocity vector differs a little bit from a directional vector. A velocity vector gives us the direction and speed of an object. So if a boat travels with a velocity vector of vector A equals to 3 negative 4 in kilometers per hour, remember sometimes the kilometers per hour is written h to the negative 1, then it tells us two things. Vector A equals 3 negative 4 lets us know the speed we are traveling as well as the direction we are going. So in this example, the direction is 3 kilometers east, 4 kilometers south. Remember that negative 4 means to go down 4, or south is also to go down. The speed of the boat is the magnitude. Now it doesn't directly give us the magnitude of the vector, but we could always find the magnitude of the vector using the equation. Using the equation, the magnitude of vector A is equal to the square root of x squared plus y squared. Remember, it's the Pythagorean theorem. This is equal to the x component, which is 3 squared, plus the y component, which is negative 4 squared. Simplifying this, I get the square root of 9 plus 16, which is equal to the square root of 25, or 25, or simplifying that, 5 kilometers per hour. And here we have the speed of our boat. To graph it, I just plot the vector. Remember, vector A was 3 negative 4, and its speed is the magnitude 5 kilometers per hour. So first of all, if I'm going to plot it, I pick an arbitrary point, so I'm going to start right there. And I am going to travel in the direction of positive 3 x component, negative 4 y component. And here I have the direction I am traveling. Now, because it's a velocity vector, I know one other thing. I am traveling at 5 kilometers per hour. So, velocity vector gives me the direction and the speed. The directional vector just gives me the direction. So I am going in this direction. And that's not working too good. Hopefully you can see I'm traveling in this direction. Whereas the velocity vector tells me I am going in this direction as well as this speed. Now, here's a problem for you to try. Remember, hit the pause button and try it. Hopefully you did this problem. First of all, let's just find the velocity or the speed of the vector. So the velocity or speed, again, is the absolute value, which is equal to the square root of the x component plus the y component. This is equal to the square root of 7 squared plus 8 squared, which is equal to the square root of 49, 7 squared is 49, and 8 squared is 64. If I simplify this, 49 plus 64 is equal to 113. So I could say that the magnitude of vector B is equal to 113 kilometers per hour. Correction, the square root of 113 kilometers per hour. Remember, in IB, 3 significant figures suffices. So I'll just go the square root of 113, and that is equal to 10.0 63014581, or it is equal to three significant figures, 10.6 kilometers per hour. Now when I plot this, I first start off by picking an arbitrary point on the graph. I'm just going to start right here. So I am going to travel 7 units x component, that is 7 units, and 8 units y component. 1, 2, 3, 4, 5, 6, 7, 8. So my directional vector is in this direction. Remember, I am traveling in this direction at a speed of 10.6 kilometers per hour. Now let's put this in a practical setting. It is 12 noon and you spot a boat traveling with the velocity vector of a equals 10 negative 5 in kilometers per hour. A, find the speed of the boat, and B, track the boat at 12 noon, 1 p.m., 2 p.m., and 3 p.m. See the diagram on the next page. Here is my diagram. Over here I have the boat, as you can see, at 12 noon. I put the vector over here so I wouldn't have to flip back and forth a lot. This empty spot represents the ocean. We are standing right here on land at this lighthouse. First, I'm going to compute the speed of the boat. Now, the speed of the boat, again, is the absolute value of A. Well, that's how we write it. It's known as the magnitude. And that is equal to the square root of the x component plus the y component, which is equal to the square root of 10 squared plus 5 squared, which gives us the square root of 100 plus 25, which gives us the square root of 125. Now I could simplify this in two ways. I could break it out. Let's see, 125 is the square root of 25 times the square root of 5. 5 radical 5, simplifying the square root of 25. Can't do nothing with the last radical 5. And the units was kilometers. I forgot what the unit was. Let me backtrack really quick. The unit was, yes it was, kilometers per hour. So the unit of kilometers per hour. Again, I could just take out my calculator and second square root 125. And that gives me this solution of the three significant figures, 1.2. Don't forget that 8 tells me to round up 1 kilometers per hour. Let me check my clock really quick. 8 minutes. All right, I'm going to stop here and continue on the next video.